Okay, so in our previous video, we have come to a point where we can express this as g into small m into capital M, that is mass of the earth, divided by, that is radius, this r e cube, this is the radius of the earth, into r, that is the distance between the point mass, that is the concentrated mass of the earth, and the object m, that is, or we can say that the distance between the object m and the earth mass. Now another thing that we can say is that there are conditions regarding r. Now r can be greater than re, r can be greater than re, or r can be less than re, or r can be equal to re. So these are the things that we know. If this is your earth mass me, m can be situated over here, r where this is greater than re, or m can be over here at the surface, or m can be somewhere inside the surface, that is, it is less, the distance is less than the radius of the earth. So these are some of the things that you come to know. Now if we are talking about gravitational force of attraction on the surface, if you are talking about on the surface, then we know that Re is equal to R. So first we will concentrate our discussion on surface of the earth. This is surface of the earth. Only then we will be able to calculate the acceleration due to gravity. Now why did the term acceleration come into play? You may ask the question why. Why is there an acceleration present because of gravity? Now let me tell you, we know that force is equal to mass into acceleration. So when there is force, you will experience an acceleration, that is a change in velocity. Now acceleration is rate of change of velocity. Now therefore, since gravitational force of attraction is also a force, gravity is a force, it's a pulling force. Therefore, due to this gravity, the objects will face some acceleration, and this acceleration on the surface of the earth, when you talk about this acceleration on the surface of the earth, this is known as gravity. Now we have defined what is gravity. If you want a definition, you can define gravity as acceleration, the force of acceleration that is due to the surface of the earth is known as gravity. The force of acceleration, or simply the acceleration due to the surface of earth, this is known as gravity. This is how we define gravity. Now during my calculation, I have come to this conclusion, this R will actually is Re. So F finally becomes G m mass of the earth into Re square. So this is my equation for the surface of the earth. Now we know force is equal to mass into acceleration. Therefore acceleration is equal to F by m. Now acceleration due to the surface of the earth, that is due to mass me, acceleration due to mass me can be written as F by m into, which is equal to G into me by Re whole square. Now, this m, if we divide force by the mass m, what is the acceleration that is experienced by this mass m? By this mass m can be written as F by m is equal to g by me by re whole square. Now this is a constant value. Now this is a constant value. So acceleration, now as you can see, g is a constant, m is also a constant, this is constant, m is constant, this is constant, the radius of the earth is constant, mass is constant, and gravitational force, that is gravitational unit, is also constant. So what we can say is that the acceleration due to gravity A is constant and it does not depend upon the mass. Force can depend upon the mass. Force depends upon mass. But acceleration is not dependent upon mass. Is not dependent upon mass, and therefore we can say that all the objects in the surface of the earth will have a common acceleration, that is g. That is why we write g to be constant. The known value of g is 9.8 into 10 to the power minus 1 meter per second square. 9.8 into 10 to the power minus 1 Newton meter per second square. This is the, you can say this is the accepted value of gravity on the surface of the earth. So now we can say that the acceleration is a constant quantity. So these are the derivation that we can put forward while writing g. So there are certain examples regarding this constant acceleration. For example, let's apply this. This is a huge rock, or you can say a brick, and this is a small feather. This is a small feather. Now we neglect the air resistance. Neglect air resistance and all such factors. So according to what we have derived, if we take these two objects with a height h, and we leave these two objects, we will see that they both will fall in the ground at the same time. They both will fall in the ground at the same time. This is the feather, and the big brick or stone will fall at the same time. Now the reason why, even though there is a huge difference in mass, but the acceleration, that is the g, is constant. G is constant, therefore they both touch the ground at the same time. And hence, we can say that even though the force is different, that is the impact force is different, but acceleration is same. So all the objects in our surface of the earth experiences the same acceleration.